Mathematics is made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydale online class. Today we want to look at integration by algebraic substitution. That is, how do we integrate when we have algebraic substitution? Let's see example. Evaluate the first one. So we want to integrate integral 3x squared all over x cubed plus 3 dx. And let's take one more question. Integral 8x plus 10 all over 2x squared plus 5 dx. Let's first look at the two questions that we have on the board. So how do we integrate this? Then if you have this type of question, we are going to look at the nature of the question. Look at the numerator. If you see this numerator, look at the numerator. You know that if you differentiate this denominator, you are going to get something in form of we are going to get something that looks like the numerator. For instance, if you differentiate 3x cubed, you are going to have 3x squared. Then whenever you differentiate a constant, is 0. So if you have this type of problem, you should know that you're going to integrate this by algebraic substitution. This is what I'm trying to say. So we are given integral 3x squared all over x cubed plus 3 dx. So without wasting time, just say let u equal to x cubed plus 3. Then what is du dx? Du dx will now be equal to 3x squared. Now I'm differentiating this now. Differentiation of constant is 0. Then if you cross multiply, what are you going to get? Because we represented everything at the denominator as u. So I'm going to rewrite the dx in form of du now. So if I cross multiply, I'm going to have this is what I'm going to have. This implies that dx will be equal to what will I get here? I want to rewrite this now. If du dx is equal to 3x squared, then I want to make dx the subject of formula. I'm going to have this to be du all over 3x squared. That is what dx will give me. So I'll come back to this question and substitute the value. I have integral 3x squared all over. I've represented everything at the numerator as u. Then multiply by, instead of having dx now, when I let u to represent what I have at the denominator and I differentiate, when I differentiate du dx, this is what I got. I make dx the subject of formula. So instead of saying dx now, I'm going to have du all over 3x squared. You realize that this will cancel this. At the end of the day, what I'll be left with 1 all over u du. And if you want to differentiate the reciprocal, like 1 all over u, it will be in u. And this is going to give me, this will give me in u plus arbitrary constant. Then what is u? This is u. U is equal to 3x cubed plus 3. So the final answer will now be in x cubed plus 3 plus arbitrary constant. And that's what we are going to get. So under integration by algebraic substitution, just look at what you are given. Either in form of, if it is fractional, that is, it is fractional like the two examples we have on the board, or if it's a product. So just look at it very well, that if you differentiate one of the factors or either numerator or denominator, are you going to get something that will cancel out from the other side? If it is yes, then you should know that if you have that type of problem, you are going to use integration by substitution to solve that type of problem. Then we go to the second example. The second example where we have 8x plus 10, 8x plus 10 all over 2x squared plus 5 dx. So how do we solve this? This is the second question. How do we solve this second question? You also look at it very well. If you differentiate the denominator, you are going to have something. You are going to have something that looks like the numerator, that has the nature of the numerator. Let's look at. If we say let u to represent 2x squared plus 5. If you represent 2x squared plus 5, then if I differentiate that, no, there's x here. We have x here. So there's x there, 2x plus 5x. So if I find du dx, du dx is going to give me 4x plus 5. So if I make du the substitute of the formula here, if I make the dx the substitute of the formula here, if I make dx the substitute of the formula, I'm going to have du all over 4x plus 5. That's what I'm going to have there. That is what I'm going to have there. Please, let's look at it very well. That is what I'm going to have there. I will not come back to the equation and substitute. I will not come back to this equation and substitute. Instead of what I have here now, I'm going to say this is 8x minus 10 plus 10 all over 2x squared plus 5x. So instead of dx now, I'll write it in the form of du. That will be du. I've represented everything here as u. We said let u be this. So I'm going to have this all over 4x plus 5. But something is common at this numerator. Something is common here. I can bring out 2. So instead of saying 2x, I can bring out 2 to have 4x plus 5. It's still the same thing. When I expand, I'm going to get this. So this can actually take care of this. So that at the end of the day, I will be left with 2 all over u du. Of course, I can bring out 2 to have integral 1 all over u du. Then if I integrate the reciprocal of this u, I'm going to have 2 in u plus arbitrary constant. Of course, we are giving the question in the form of x, not u. We now recall from here that u. So this will now be 2 in, what is u? 2x squared plus 5x, then plus arbitrary constants. And that is what we are going to get there. That is what we are going to get there. So that's what we are going to get there. So under integration by substitution, algebraic substitution, you have to look at the question very well. Look at it, especially when it is fractional. You look at it and see what you can do. If you differentiate maybe the numerator or the denominator, are we going to get something in that form? If it is yes, then go ahead and do that. Then let's see another example. Let's see 2 more examples. Then we go. Evaluate. In this case now, it's a form of product. You know, I said it can be either fractional or product. In this case now, we have 4x cubed plus 9x plus 2. Then I have x squared plus 3x cubed plus 2x. Everything raised to the power 5 du. That's the first question. Then the second question. Here, I have integral x squared ex cubed raised by x cubed dx. So these are the 2 questions that we want to look at. So how do we solve this question? That is what we are about to do now. So under integration by substitution, you have to look at it very well, especially when it is product or when it is a form of quotient, fraction. Look at the first one. It's very simple, but we are the one that will observe it. Under integration, nobody will tell you what to use. You look at the question very well and you reason it. You're going to reason out what you are going to use. So nobody will tell you, but well, if the examiner is very nice, he might tell you integrate by this or integrate by that. Look at, when you look at this now, if I differentiate this now, I'm going to have something like 4, I will have something like 4s, I have something like 4s cubed plus 9s squared, then plus 2. If I integrate that, let's look at it very well. If I integrate that, I'm going to have something in the nature of the question that we are given. So here we have 4s cubed plus 9s squared. This 4s cubed plus 9s squared. The square here. So this is 4s cubed plus 9s squared. So if I integrate, if I differentiate this now, I'm going to get something of this nature. This is what I'm trying to say. We say let u equal to s cubed, s squared, s raised to the power 4 plus 3s cubed plus 2x. So what is du dx? Du dx will be what? 4s cubed plus 3 times 3, 9s squared plus 2. That is what we are going to have. So in this case now, I'll make dx substitute of formula. That is, I will say dx will be equal to, I will make dx the substitute of formula. Dx will be equal to du all over what I have here, 4s cubed plus 9s squared plus 2. So what am I going to do now? The next step is that I will come back and substitute. I'm going to substitute for the value of, here now, this is s raised to the power 4. So I will now come back to this equation, to this question. As instead of dx, I'm going to substitute this value. And let's see. If I substitute back, what am I going to get? That is the next step that we're about to do now. So if I substitute back, what am I going to get? Let's look at it together. So if I write the question, I say integral 4s cubed plus 9x squared plus 2 multiply by s squared plus 3s cubed plus 2x, everything raised by 5. Multiply by, instead of dx now, I'll change it to du all over 4s cubed plus 9s squared plus 2. That is what I'm going to have. So if I do that, integral of everything here, if I do that, I will realize that this can actually cancel this. They're going to cancel out. That will cancel out. Then what else do we have? We have represented everything here as u, so that I'm going to have integral u raised to power 5 du. That's what I'm going to have. Please look at it very well. We have represented s squared plus 3s cubed plus 2x as u, and that's what I'm going to have. Then at this stage now, it's very simple. How do I integrate this? When I integrate u raised to power 5, that will be u raised to power 5 plus 1 plus 5 plus 1 plus arbitrary constant. Then I'm going to have u raised to power 6 all over 6 plus arbitrary constant. We are given the question in the form of x, not u. So we now recall, what is u? We decide to represent u. U is same thing as s raised to power 4 plus 3s cubed plus 2x. Everything raised to power 6 all over 6 plus arbitrary constant. And that is what we are going to get. So under integration by algebraic substitution, you look at the question very well. It is the nature of the question that will actually determine what to do. So if you look at the question, that if you differentiate one, will you be able to cancel out? If it is yes, then you know that question is under algebraic substitution. So we go to the second question, which will be the final question for today. The second question under example 2, where we have integral s squared e s cubed dx. So what do we do here? So look at it very well. You have something in the form of s squared, s cubed. That tells us that something can actually cancel out. We just say let u to be equal to s cubed, so that du dx will be equal to 3s squared when I differentiate this. Then if I make this x subject to the formula, I'm going to have dx to be equal to du all over 3s squared. So I'll go back to the given question and substitute. This is s squared. Then e, we decide to represent everything here as u. That will be u multiplied by du. S squared can actually cancel s squared. So that at the end of the day, from there now, at the end of the day, I'm going to have integral e raised to power u all over 3 du. So I can bring out 1 all over 3. So that at the end of the day, I will have eu du. When you integrate exponential function, you get the same value, provided that the coefficient of this power is 1. But if the coefficient of this power is more than 1, we are going to use it to divide everything. So in this case now, if I integrate, this is 1 all over 3, multiply by, if I integrate eu, I'm going to get eu back, exponential u, then plus arbitrary constants. So at the end of the day, I'm going to have 1 all over 3 exponential. What is u? We use same thing as s cubed plus arbitrary constant, and that will be the final answer that we're going to have. So I'd love to stop here because of our time. In the next video, we are going to continue from there. We will continue from there in the next video. So this is just example under integration by substitution. Thank you, and God bless you all.
Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.